Welcome everyone to a new Professor SEO video. So as you guys have requested for me to make a specific video for RSA and authentication. Again, I said it's like the same thing, so I was like, okay, let's just do it all over again, okay? But this time I will use it for like authentication, okay? So it will be quicker than before. So RSA. Step 1, generating the keys. Choosing a P and a Q where both P and Q are prime numbers. Large random prime numbers, because this is where the RSA is secure. This is why RSA is secure, because P and Q are very large, and calculating n or finding the factors of n would be kind of impossible, or like computation infeasible, or like time consuming. Basically, it would take thousands of years or like even more, depends on the length of the P and Q. Now we take the torsion of n, which is also equal to P minus 1, Q minus 1. This is also due to the torsion property that says torsion N, or like, sorry, torsion P times Q, torsion of P times Q can also be the torsion of P times torsion of Q, where torsion of P is equal to P minus 1, and torsion of Q is also equal to Q minus 1. Now that we have, now we select E. Now select E, where E is a number that is co-prime with torsion N, which also means that the GCD between E and torsion N is equal to 1. Now we calculate D, where D is equal to E inverse mod torsion N. Again, we took the torsion of n, we are using the torsion of n such that we can build a mathematical relationship between D and the E inverse, such that when we multiply D and E, we get 1, okay? Now, what will be public, again, is the N and the E. What will be private is the N and the D. Now, when it comes to verification, the only one who has the D is me, the one who generated the message, the key, right? So what will I do is I'll take message and take the part of D on N, which is equal to C. Now I take this C and send it, okay? Now if the receiver is able to decrypt this message using my public key, it means that I am actually the one who sent this message, because the only one who has the private key is me, right? And again, remember the property that says any private key should decrypt public key, or a message encrypted by a public key, and any public key can decrypt a message encrypted by a private key, vice versa, such that when I receive this ciphertext, I have the ciphertext, I will get the message by encrypting it using my public key. And because I was able to decrypt the cipher using my public key, means I'm the one who sent it. Yeah, this is how verification can work using RSA, etc. Thank you for watching, everyone. See you in the next video.